right, so you've looked at these two discussion questions. Let's go ahead and go through them. When a car comes to a stop on a level highway, what force causes it to slow down? And then when the car increases its speed on the same highway, what force causes it to speed up? Explain. All right, so when a car is slowing down, the velocity and acceleration have to be in opposite directions. That's what it means to slow down. In order for this to occur, there must be a net force opposite the direction of the velocity. So if the velocity is this way, there must be a net force in the opposite direction, because a net force is what causes the acceleration. So in our case, friction between the tires and the road is pointing in the opposite direction that the car is moving. That will cause it to slow down. Now, on the other hand, if we're going to speed up, in speeding up, velocity and acceleration have to have the same direction. That means the velocity and the net force have to be in the same direction. And so we need some net force pushing forward. So I need a force forward more than backwards. And so friction also provides that same force. So just the same as like if you try to stop in the winter and it's icy out, you'll skid forward. And then once you come to a stop and you're ready to go again, you slam on the gas, your wheels spin. In both cases, low friction means you can't slow down or speed up as effectively. Now the second one says, a small compact car is pushing a large van that has broken down. And they travel along the road with equal velocities and accelerations. While the car is speeding up, is the force it exerts on the van larger than, smaller than, or the same as the force the van exerts on it? And then, which object, the car or the van, has the largest net force on it? Or are the net forces the same? Okay, so if a car pushes on a van, that means the van pushes back on it. Third law. So the forces are equal and opposite between them. Now, when we talk about the net force on the individuals, we're thinking again about the wagon and the horse. Okay, the net force determines the acceleration of each of the individual objects. And so when I look at the net force on, say, the truck, that determines the acceleration of the truck, or the net force on the car determines the acceleration of the car. And so since it tells me they both have the same acceleration, the one with the larger mass, the truck, must have a larger net force on it in order for it to have the same acceleration. So because the truck is broken down, there's no friction helping speed it up or slow it down. So that means the car has to supply all of that extra friction to speed it up and slow it down. So maybe the car has 10,000 newtons of friction pushing it forward, but the truck has 7,000 newtons of force pushing back, meaning 10 forward, 7 back. Overall, the car has 3,000 newtons accelerating it forward. Where the truck, because the car is pushing forward with 7,000 on the truck and the truck is pushing back with 7,000, the truck has 7,000 newtons. So it has a larger net force on it because its mass is larger in order to produce that same acceleration. The car and the truck don't get to choose how that works. The acceleration will determine that. So if one's pushing harder than the other one, maybe that truck is causing that car to accelerate at a different rate, or if you push really hard on that truck's going to accelerate more than the car, and then they won't be pushing anymore.